Hi, geometry. Welcome to 7.5, tangent ratio. So this is one of the 6 trigonometric functions. So let's think about this. If I have a right triangle, this is with right triangles, I have little side A, little side B, little side C, we can make ratios of sides. A over B, B over A over C, C over A, B over C, C over B. How many are there? 6. That's why there are 6 trigonometric functions. Now these work with right triangles only. Okay, I have to keep checking to make sure you're recording because this is take 2. I will have my calculator handy. We will be doing the trig functions on there. And here we go. Let's start with our warm-up. And out of the 6 trigonometric functions, we are going to be dealing with tangent. Tangent is probably the most widely used, especially for heights of random objects, and that will come up with our real life values. I also have a ruler, okay? So the problem with my ruler is the centimeters, it's kind of rubbed off a little bit, so I'm going to have kind of estimates here, but I'll do my best. Okay, so here we go. Find the values of the variables. So this is our geometric mean. I want to first find x. That's my altitude. Remember the altitude rule? X squared is equal to 3 times 8. 3 times 8 is 24. So x is equal to the square root of 4 times 6. The square root of 4 is 2 times the square root of 6. There's your exact answer. You can take 2 times the square root of 6 in the calculator to find your estimate if you want. Now let's find y squared. Y is the shorter leg, so we're going to be dealing with the shorter leg of the whole triangle, so we'll be dealing with this 3. Y squared is equal to 3 times the whole length, which is 11. 3 times 11 is 33. So y is equal to the square root of 33. And again, if you want to know the approximate answer, you can put in the calculator. How about this one? We have a special triangle. This is a 45, 45, 90 triangle. And that means this segment's the same as that. So when we want to find x and y, basically find one of them, and I'm okay. So you're going to start off with your formula. So if we recall with our formula, x square root of 2. And this is the information that we're going to use. So x square root of 2 is equal to 20 times the square root of 3. I need x by itself. Let's kind of go like this. Divide both sides by square root of 2. These cancel. X is equal to, I have to rationalize my denominator. So I'm going to multiply by the square root of 2 times the square root of 2. Remember, I'm multiplying by a form of 1. So when you multiply by a form of 1, you're not changing your answer, you're just changing its appearance. So square root of 3 times square root of 2 is square root of 6. So I have 20 square root of 6 in the numerator, and then in the bottom, square root of 2 times square root of 2 is square root of 4, which is 2. And then of course the 2 and 20 reduce. I'll give you 10 times the square root of 6. So there's the answer for both of these x's. All right, here we go. Here's our fun stuff. The right triangle ratio. Okay, so just a little activity just to show you how this is going to work. Measure both sets of legs. Remember on a right triangle, like if I look at this right triangle, this is a leg, the blue line, and then the orange line. So we're going to measure all of these. And bear with me. I measured them earlier. So this is about 3 centimeters. 3 more centimeters. About 2.5. And then I'm going to measure the vertical lengths. Okay, so you want to be as accurate as possible. This is about 1.6. 3.2. And 4.5. And now let's record this information, okay? So we need to know about a little bit of vocabulary. Adjacent means next to. Opposite is direct opposite. So triangle AB1C1, that's our smaller triangle. The adjacent leg, so we're looking at the small triangle only, the adjacent leg, the one next to, I should have put A in the middle of all these, right? Yeah, next to angle A. So I have these all written down funny. How about that? Just notice it now. In any case, this is a 3. The opposite leg would be 1.6. So take opposite divided by adjacent. And I'm going to put that in the calculator. I don't know if you probably can't see it. 1.3 divided by 6 is, whoops, 1.6 divided by 3, silly. 1.6 divided by 3. Yeah, that's better. Okay, so you can see it a little bit, 0.533. Okay, now let's do the next triangle. Okay, adjacent leg, that's this whole length. That'll be 6 and 3.2. Take opposite over adjacent. So 3.2 divided by 6. 3.2 divided by 6. There you go, 0.533. Not sure why it's not coming out. Uh-oh, what do you notice? And last but not least, this whole length, 3 plus 3 is 6, 7, 8.5. 4.5. Divide the opposite over adjacent. 4.5 divided by 8.5, we get 0.529. Okay, these are all pretty close. Explain why the proportions are true, okay? So these are all the opposite over adjacent proportions, okay? So why are they all true? Well, these are similar triangles by angle. They all share angle A, and they all have a right angle, okay? So angle. So remember, if it's angle, the angles are the same measure, the sides are proportional. Hence, it's happening. We have a little probably bit of an error there, but that's all right. What else do you notice about the lengths? They're all constant. The ratios are constant, okay? So we're looking at angle A, so I should have written all those. In any case, moving on. Take a while, guess which trig function we're talking about here. The title, tangent. Tangent is going to be your opposite over adjacent. So here we go. Trigonometric ratio is a ratio of lengths of two sides in a right triangle. You will use the trigonometric ratios to find the measure of a side of an acute angle. Or an acute angle in the right triangle. You only look for the angles when you do the inverse. That's later stuff. The ratio of the lengths of the legs in a right triangle are constant for a given angle measure. Okay, so remember, the sides are always proportional, so you will have a constant. Also keep in mind we are dealing with right triangles and constant for a given measure. All right, so this is called the tangent of an angle. Okay, parts of a triangle. So according to angle A, this is opposite, okay? This is adjacent, side next to. This is your hypotenuse. So we're not going to be playing with the hypotenuse at all. We're going to be doing the opposite and adjacent. So let triangle ABC be a right triangle with acute angle A. Okay, notice it's not written the right way. I'm taking this stuff right out of our book. The tangent of A, written as tangent A, is defined as follows. Opposite over adjacent. So the length of the leg opposite over the length of leg adjacent. So if here's A, opposite would be BC, adjacent would be AC. You can use the little letters too, A over B if you wanted. Okay, so what I'm always going to do is tangent of A is equal to opposite over adjacent. So I'm going to write it like that. Okay. Hypotenuse I would abbreviate as HYP. Now, complementary angles. This is actually really important. In a right triangle, angle A and angle B are complementary. That's when angle C is the right angle, okay? Remember what complementary angles do. They up to 90. So let's think about this. Let's make a 3, 4, 5 triangle. Let's put A here, B here, angle C. These two have to equal 90. Remember, complementary angles add up to 90? So there we go. And if we have a 3, 4, 5 triangle, let's take a look at this. Find the tangent of A. And this is how it's going to work. Tangent of A is equal to opposite. So according to A, opposite is 4. over adjacent. Next to A is 3. Now let's find tangent of B. Okay, here's B. Tangent is opposite over adjacent. So any letter doesn't matter. So opposite of B would be 3. Adjacent is 4. So one thing I want you to know, complementary angles, those ratios will flip. There's more to that in the future. All right, let's look at our first example. Find tangent of A and tangent of C. All right, so now we have B as the angle, the right angle. Tangent of A equals opposite over adjacent. All right, so here's A. The opposite side would be 24. Adjacent would be 7. If it reduces, I'd ask you to, excuse me, or just leave it as is. Tangent of C. Okay, so now here's C. The side opposite would be 7. Adjacent would be 24. And what do you notice? They're just the flips. Because the angle A and C are complements. Okay, they absolutely equal 90. So the ratios will just flip. Now, how do we actually find a side length? Remember when we had special triangles, we had formulas x square root of 2, or x 2x and square root of 3x. Well, if you know the trigonometric ratio, or the trigonometric values, you only need to know one side also. Okay, according to this angle, I have opposite, and this is adjacent. So, tangent of my angle A, tangent of 40, is equal to 7 over x. Notice I put tangent of 40 over 1, so I have a proportion. In order to solve, cross multiply. So x times tangent of 40 is equal to 1 times 7. And I need x by itself. It's being multiplied by tangent of 40. So I'm going to divide both sides by tangent of 40. So I'm still applying the same information we've done before. It's just now I've got these weird letters in here. So x is approximately. Now let me show you how to put this in the calculator. Oh, by the way, calculator. So the first thing we need to do is check the mode. Okay, so right here is mode. We press mode, and if you look, it's kind of hard. It's really hard to see. Right here, it's highlighted degree mode. So you must be in degree mode. Okay, so once you do that, now take 7 divided by tangent of 40. So I have, I'll show you the keys, 7 divided by, here's tangent of 40. Okay, so I don't know if you could see, can you see that a little bit? 7 divided by tangent, this is crazy. I don't want to wait. There we go. 7 divided by tangent of 40. I'm going to press enter. You get 8.3422. So 8.3442. Please go 3 decimals. You can truncate it, meaning just stop after 3, or round it after, to the third one. So it's your choice. So this is about how long that's going to be. Pretty nifty, huh? When I was in school, we used charts. Maybe I'll take out one of those charts and show you. Okay, next page. Ooh, let's find the height of a tree. Okay, so find the height of a tree to the nearest foot. I don't know if you could see this. I'm going to help you out. This angle is 31.8. This is 71 feet. And we don't know the height of the tree. When it's a vertical distance, I like to call it y, kind of like the y-axis. If we were looking for the horizontal distance, I would call that x, for like the x-axis. But here we go. Remember, tangent of some angle is equal to opposite over adjacent. Okay, so here's my angle. Tangent of 31.8 is equal to opposite, I don't know. Adjacent, right next to it, 71. Write that over 1, so you have a proportion. Cross multiply. Y is equal to 71 times tangent of 31.8. Be careful. You could write like this, tangent of 31.8, but if you do this and put it in the calculator, it'll turn out to be wrong. You would have to close parentheses here, okay? So that's why I always recommend put that constant in front of it, okay? So put this puppy in the calculator. The calculator can't see. I wonder if I can make it dimmer. Let's see. Oh, well, how about that? 71 times tangent of 31.8. There we go. 44. Hey, it's a 44-foot tree. It's pretty tall. So y is about 44.0219 feet. Tall tree. Not as tall as the one we did in class today. All right. Use special right triangles to find 45, 30, 60, 90-degree triangles. Okay, the tangent of each one. So and these are special, okay? These will be famous. When you start talking more about trigonometry functions, this will come up. So here we go. Tangent of 30. Remember what tangent means? I'll write on the side. Tangent of some angle. A lot of times you use the Greek letter theta is equal to OPP over adjacent, opposite over adjacent. So, according to 30 degrees, the side opposite of this angle is way down here. That's A. And adjacent would be right next to it, square root of 3 over A. Notice, A's will cancel, and you get 1 over square root of 3. But we should rationalize that. So times square root of 3 over square root of 3. 1 times square root of 3 is just square root of 3. Square root of 3 times square root of 3 is square root of 9, which is 3. So I'm going to show you approximately what that value is. Square root of 3 divided by 3 is about 0.577. Okay, but watch this. Remember, we were working out tangent of 30. You ready for this? Tangent of 30. Enter. 0.577. Amazing, isn't it? Now let's hit tangent of 60. Okay, so here's the 60 degree. Remember, tangent is opposite over adjacent. So according to this angle, opposite would be square root of 3 over A. Sorry, square root of 3A. Adjacent is just A. Remember, adjacent means next to. What do the A's do? Cancel. So let's put square root of 3 in the calculator, and you get 1.732. And what do you think we're going to get when we press tangent of 60? So tangent of 60, press tangent. Remember the tangent button's right there? 60. Enter. Same thing. Ho ho. Impressed yet? Okay, because basically they're doing the same thing that we're doing. It's the ratio of size is what the calculator's doing. How about tangent of 45? Remember, tangent is opposite over adjacent. So, doesn't matter which 45 you want to pick. Opposite is A. Adjacent's A. Which is equal to 1. Watch what happens when I do tangent of 45. Is equal to 1. So, here is our homework assignment. And there's our Common Core Standard. And I hope everybody has a very nice evening. Take care.